Okay, differentiate y equals x cubed. It says here from first principles, yeah? So remember with first principles, the approach I tend to take is I choose 2 points, P and Q. Okay, it's quite thorough this way then. Because point P is any general point X on that curve, okay? So if my X value is X, my Y value then, well, to work out Y, you just substitute the X value in here, yeah? So if it's a general point X, my Y value will be X cubed. And what I do then is, of course, with differentiation, we go across a little distance, H, yeah? When we do differentiation from first principles to my point Q. So my point Q, will have X value X plus H, okay? That's what the X value will be. And you substitute it in then to here to work out what your Y value will be. So you just got to cube your X value, haven't you? So that'll be X plus H all cubed. Okay, so there you go, there's your coordinates there. So then to work out dy dx, we'll start off by looking at the chord P to Q. Okay, and we're going to work out the gradient of that chord which joins those 2 points. So the gradient of chord P to Q. Now remember, we use the formula, don't we, which we use from coordinate geometry to work out the gradients. The difference in y's divided by the difference in x's. Okay, so in this case, I'm going to call this my x2, y2. I always call the q coordinate x2, y2, and then the p coordinate x1, y1. So you get y2, which is x plus h all cubed. Take away then my y1, which is x cubed. And then on the bottom, we'll have my x2, which is x plus h. Take away my x1 then, which is just x. So you know then that will always cancel and you just get h on the bottom. So you just got to expand this then at the top. Now you could expand that by doing 3 brackets, or you could use the binomial theorem. Yeah, so remember the binomial theorem. Okay, we use the Pascal's triangle like that, yeah. And then, you know, if you've got your general result, we can write it up here, we'll have enough room here, a plus b cubed. So remember, I think it's easier to use this because you get used to it and it's much quicker. Remember with a plus b cubed, so a to the power 3, a to the highest power. So coefficient is always 1, isn't it? So I never really bother look. I know the second coefficient then is 3. A then of course you reduce your a, so it'll be a squared and then b. Third coefficient is 3 and then a b squared, and then finally then you've just got coefficient 1 b cubed, yeah? So what we can do is just use that result in here, so slightly longer line this time for a fraction, h on the bottom. So if we just substitute in, you know, that would be my x, won't it? And that'll be my h. So I'll have x cubed there, plus 3x squared h, plus 3x h squared, plus then, what will that be, h cubed, yeah? Take away then at the end the x cubed here. Okay, and what you'll find nicely then is those x cubes cancel. Okay, and on the top, you'll always notice this, h is a common factor. H goes into every term. So what I can do is factorize out h on the top now. So in a bracket, h times what gives me this? Well, it'll be 3x squared. H times what gives me this? Well, it'll be 3xh. And h times what gives me that? Well, that'll be h squared. Okay, all over h. H's cancel. H on top, h on the bottom, so they divide through. So you end up having 3x squared plus 3xh plus h squared. Now remember, this is the gradient of the chord PQ, isn't it? What I actually want dy dx at general point P. Okay, so remember the process of differentiation from first principles is you let h get smaller and smaller, so you reduce that distance across there, which means Q moves down the curve. Okay, so your chord, okay, becomes ever more closer to that tangent, and in fact as you let h go to 0, the chord literally becomes the tangent. Okay, so that's why we say this limiting process, we limit h to 0. Okay, as h gets smaller and smaller, it will tend towards that gradient. So we can essentially say then, look, dy dx is equal to the limit as h goes to 0, and you have to state this in the exam, of 3x squared plus 3xh plus h squared. Well, if h goes to 0, then all of that's 0, so you're just left with 3x squared, which is what we expected, yeah? Okay, so in part B then, it says differentiate this, so we've got 9x to the power 5 over 4 minus 8 over the cube root of x. So I've written that down there, yeah? Okay, so before we differentiate this, we must remember to get all the x terms at the top. So the first term is fine, it's just this second term here. We need to take that up, yeah? Because you can't differentiate it like that. So, because it's cube root, okay, cube root, remember, is the power third. Okay, that's what that corresponds to. Cube root is power third, just like square root is the power half. Okay, cube root is power third, but it's power third on the bottom, so when I take it up, it'll be minus 1/3, yeah? So differentiate, you get dy by dx. Well, what you've got to do then, of course, bring the power down, so 5 over 4, bring it down. 5 over 4 times 9, okay, is 45 over 4. Okay, now in the exam, I would always check that, right? So you literally do, look, 9 times 5 over 4. Okay, and it'll just do it for you, right? Just check that in the exam because you don't want to make a mistake. And the same here, 5 over 4, take away 1. Well, I know that's 1 over 4, but use your calculator to check. So 5 over 4, take away 1, because you've got to take away 1 from that power, haven't you? And you get 1 over 4. The same here, bring the third down, the minus third down. So minus the third times minus 8 is plus 8/3, and then x then. And if you take away 1 from that, you get minus 4/3. Okay, and we've got our answer.